Hello friends, welcome to the Design Pattern course. Before we start with our lecture today, a small introduction to what this course will be. This course will be an advanced software engineering course centered around the design and architectural concepts while developing a software. There is a small prerequisite for this course that you should know the fundamentals of object-oriented programming and proficiency in at least one object-oriented programming language. Also, your past personal software project or work experience will help you better understand and apply design patterns. But one thing to remember is, in this course, I will explain you the core concept behind every design pattern. But this won't be effective unless you read and try using and implementing the design patterns yourself. The best way to get in-depth knowledge in design pattern is to read a book named Design Patterns: Elements of Reusable Object-Oriented Software by Eric Gamma. I will paste the link of this book in the summary. Again, my videos will help you in easily grasping the core concepts, and then for in-depth implementation, you can refer the book. So, what are we waiting for? Let's begin the course. One of the first questions that should come to your mind is, what is design patterns and why do we need it? I will break this into two parts. First, let's see what does industry define design pattern as. A design pattern is a solution to a problem within a given context. This is not self-explanatory at all. Let me make this statement a bit easy. To make you understand the above statement, let me give you a small example. Let us assume you walk out of your house in the open world for the very first time. Walking on the road, suddenly it starts raining. When you look around, you see people using umbrellas for not getting wet in rain. You understand this is a pattern and you can reuse it to not get wet in the rain again. So using an umbrella here is a solution to a problem of getting wet, but in a given context of rain. And this solution is reusable by anyone who does not want to get wet in rain. If you change the context, the solution is no longer valid. So, assume you told your friend that umbrella is a pattern that will help you avoid getting wet. Hearing this from you, he goes to a pool party where a bunch of his friends try to throw him into the pool. Taking a suggestion from you, your friend opens the umbrella and then jumps into the pool. Alas, he still gets wet. Why do you think the solution didn't work here? Yes, correct. Because the given context had changed from rainwater, it moved to pool water. So once the given context has changed, the solution is no longer usable. Again, this is just a general definition that does not explain the in-depth meaning of design pattern. But don't worry, that is why I am here for. Once you reach the end of this video, I will make sure you understand the meaning of design pattern in Norman Mann's language. So hold your thought here for a moment. Till that time, let's move on to why design patterns. To make you understand why, I have a small story. So the story begins like this. Once there was a king who had a very big kingdom. Right in the middle of his kingdom was a big river flowing that was causing people a lot of pains to move from one part of his kingdom to another. Recognizing this as an issue, the king decides to build a bridge for the people of his kingdom. He calls a construction engineer and tells him to build a bridge for the people to cross over the two sides of his kingdom. Taking a note of his requirements, the engineer goes back and assembles a team, orders the bricks, and starts building the bridge. Using brick after brick, it takes the engineer and his team a time of around 6 months to convert the raw materials into a finished product, which is the bridge. Now that the work is done, the construction engineer comes to the king and tells him that the bridge is ready for people to use. Till now, the story seems pretty reasonable, but now there is a small twist. The king looks at the bridge and feels that if the center of the bridge is to have a 10-degree tilt to the right, it would look really fashionable and would stand out as compared to other kingdoms. So he orders the construction engineer to go and change the center of the bridge to have a tilt of 10 degrees to the right. Hearing the renewed demands of the king, the construction engineer revisits his design for the bridge. He soon understands that the bridge was built as a single unit using small bricks, and right now it would be completely impossible to change the shape of the center of the bridge. So he goes back to the king to tell him that this is not possible. This makes the king really annoyed, and the king does not pay for the bridge to the construction company, and the construction company suffers huge losses. Bearing these huge financial losses, the construction company hires a very experienced construction engineer to consult on how they can improve and make their building process more flexible to customer demands in the future. The experienced consultant starts with studying the various bridges that were built by the construction company. Once his study completes, he finds that there are three patterns that are regularly followed by the construction company while building the bridge. First, he saw that the construction workers build the upward climb of the bridge. Then they go on to build the center of the bridge, and then they build the downward climb. Even though this is one single bridge, these three tasks are independent segments of the bridge. So, the consultant engineer advised the company to break the bridge into separate sections which can be built independently. He told the construction company to have a hollow iron cast that resembles the upward climb and can be used to build upward section of the bridge. Then they can have similar cast for downward section. The middle section can be as per customer requirements. Once these three sections are done, they can be brought together and interconnected using metal hinges. In this, the bridge will be configurable and flexible to changes and will be easy to maintain. Also, this will enable each segment to be reusable. So, the individual iron cast for building section of the bridge here resembles the solution to a problem of design changes in context of a bridge. If you think closely, the consultant basically upgraded the unit of building block of the bridge from a single brick to a single section of the brick. That means now the bridge is not a single entity anymore. It is an entity that is made up by interconnection of sections which are easily configurable and reusable. Now let's move our focus with the same thought in mind to software industry. Assume the bridge here to be the software you're going to build, and let's understand what is the fundamental block of unit that we get in our software industry. If you look closely, during the first generation, the fundamental unit of construction for us was the machine level instructions. Even writing a very small program required thousands of lines of machine level instructions. Soon the engineers understood that this is not going to be easily maintainable and reusable. So in the second generation, they upgraded to bring the smaller fundamental blocks to build a bigger one in terms of data types and loops like int, boolean, for loops, and while loops. Over the time, the software engineers started building more sophisticated softwares. They soon understood that data types and loops are now too small a fundamental block to build sophisticated softwares. So in the third generation, they upgraded the unit of construction to an object and moved towards object-oriented programming, which helped them build more sophisticated softwares, maintain easily, reuse it in separate softwares together. In the later part of the 19th century, the software industry grew leaps and bounds. Here were the software engineers who were building large enterprise applications that used to communicate with hundreds of different softwares to exchange data and compute results within a fraction of a second. Now, the objects as the fundamental unit of construction was no longer feasible. So, in the year 1994, a person named Eric Gamma approached his three friends and persuaded them to think along same lines in the software sense. He said that if the software can be divided into independent modules, which are commonly used in all applications, then maintaining it and reusing it will be absolutely easy. Not only that, the software will be able to adapt to any customer changes without significant change to his entire code base. Following this thought, Eric Gama and his 3 friends started research in various softwares in different domains of software industry. They found out that there are 23 patterns that all these software from different domains follow to build a large enterprise application. They thought that if these 23 patterns can be standardized and made as modules, they can be reused by various softwares in different domains as well. So they came up with a book named Design Patterns, Elements of Reusable Object-Oriented Software, where they explained these 23 patterns and which are famously used within the entire software industry in today's 21st century. Also, Eric Gama and his 3 friends, for their contributions, are famously called as Gang of 4 in the software industry. Now, let's come to the first question that came to your mind. What is design pattern and why is it needed? Let's define design pattern first. Patterns offer higher level of abstraction and are a larger unit of construction in comparison to the fundamental building block. Why is pattern needed? Because it simplifies the life of a software engineer in building a software by making modules of that software that are configurable and independent, as well as very easy to reuse. Today's software industry has a very large community of software engineers that are researching various softwares in different domains to see what can be standardized as a design pattern. This community is known as pattern languages of programs. Even though Eric Gama only defined 23 standardized patterns for the software industry to use, this community has defined more than 10,000 patterns that can be used by the software industry. If you are interested in knowing those 10,000, you can go to the website www.hillside.net/patterns. This brings us to the end of this video. I hope by now you have got a small essence of what design pattern is. And in my coming videos, I will only try to build upon the knowledge you gained today. Thank you, and please subscribe to my channel. You can also submit questions in comment section and I will try my best to answer. Also, if you feel that there are topics that I did not cover and needs to be covered, let me know by email, crackthecode@hotmail.com, and I will ensure that I cover it. Once again, thanks, and please subscribe. My next video will be on fundamental of design patterns.